Hope you are doing great today. Today we are going to work on some problems on relative frequency and stem and leaf plot. So we will start with a relative frequency problem. Okay. So here is the question. How far away from home would you would you like the college you attend to be? Now the same questions, as we'll see, same categories of distance away from home were asked to students and to their parents. Okay, so as I said, different distances away from the home. So there is a column for students and there is a column for parents. These were the people who were surveyed. Okay, so students is the first category is less than 250 miles, and 3,494 students would like the college to be located less than 250 miles away from the home. For the parents, the total number of parents who agreed to that category is 1,233. Then the next category is between 250 and 500 miles. Okay, and 500 miles. For student, number of students who responded to that category is 2,980. For parents, it was 796. Okay. Next category is between 500 and 1,000. And for students, number of students who responded or said yes to that category is 2,055. For parents, it was only 334 parents who responded yes to that category. And the last category of distance away from home is more than 1,000 miles. And for students, it was 1,747 students who responded yes to that category. For parents, it was 206 parents who responded yes to that category. Part A, ask, explain why you would want to use relative frequency when constructing a comparative bar chart. To compare ideal distance from home, ideal distance of college from home. For students and parents. Okay. Part B. So that's part B, construct a comparative bar chart. Bar chart from this data. And the last part is part C. Compare on similarities and differences in distribution of ideal distribution. This is you. Distribution of ideal distance for students and parents. For students and parents. So the first part they ask, explain why you would want to use relative frequency for constructing a comparative bar chart to compare ideal distance of college from house, ideal distance of college from home for students and parents. Question is, why do you want to construct a relative, or why do you want to use relative frequency? Okay, and that is pretty simple to answer. Look at the students. Look at the number of students in each category. Significantly different from parents. So if you add up all the categories for the students, the total number of students surveyed, you will find it is 10,276. And if you add up all the categories for the parents, you will find it is 2,569. As you can see, the total for the students is significantly greater than the parents who were surveyed or who participated in the survey. You cannot compare the actual numbers. You have to convert number for each category of distance for students as well as parents into relative frequency. Again, what is relative frequency? It is the decimal relative to the total. So you take the frequency of each category and divide into it, or divide it by the total in each. So for example, the first one will be 3494 divided by the total is 10,276, and that works out to 0.34. So here is the relative frequency for each category relative to the total. What does this number 0.34 means? 34% of the students want the college to be located less than 250 miles. You can continue with this. Next one will be 2980 divided by the total 10,276, and that works out to 0.29. The next one is 0.20 for this one, and this is 0.17. What does it mean? 17% of the students want the college to be located more than 1000 miles away. So we can do the similar calculation of relative frequency for each category. For the parents, the first one will be 1233 divided by 2569, and it is 0.48. The next one is 0.796 divided by this total 2569, and it is 0.31. The next one is 0.13 and 0.01. Explain why do you want to use, we want to use relative frequency because the totals are different. Relative frequency because the totals are different. Because the totals are different. For students and for parents. Same number of students and parents were not surveyed. So you have to take the total of each category and divide into it the grand total for each class, for the students and for the parents. Okay, so basically we are constructing a relative frequency, converting each data to relative frequency because the grand totals are different for the students and parents. Now we have to construct a comparative bar chart for this data. So we will have relative frequency on the vertical axis, and we will have the four category. So less than, the first one is less than 200. Next one will be 200 to less than 500. Next one will be 500 to less than 1000. And the last category will be more than, greater than 1000 miles. Okay, so we will have relative frequency on the vertical axis. If you look at the number, the highest, the lowest is, what is it? This is 0.08 actually. The lowest is 0.08 and the highest is 0.48. Okay, so if we do, we start from 0, so 0, then 0.1, 0.2, 0.3, 0.4 and 0.5. So the height of each bar will be the relative frequency. So relative frequency on this. Okay. So we will have two bars touching each other. One for the students, one for the parents. Okay. Let's take a look at the first one. It's 0.34 for students and 0.48 for the parents. 0.34. 3 and 4. So somewhere over here. This is students. Then we'll do the parents, which is 0.34, 0.48. So the height of that bar is higher than this one. So 0.48 actually will be somewhere over here. So this height is 0.48. The height of each bar is a relative frequency, and this is I will write in blue ink. This is 0.34. So as you can see in the first category, parents are relative frequency is higher. They would much rather want their children to stay or go to college less than 250 miles. Okay. Next one is between 250 and 500. For students it's 0.29, for parents it's 0.31. Okay, so 0.29 is close to 0.3. So somewhere over here is students. So blue is student and red is parents. So this is parent. Okay. And for parents it's 0.31. Fairly close. So slightly higher. So let me draw with the red point. For the parents is 0.31. Okay. So this height is 0.31. Again, the heights of the fars are the relative frequency, and this is, I'll do with the blue ink, is 0.29. As you can notice, only in these two categories the relative frequency are very close. So both the students and parents like this category, that they want the college to be located between 250 to 500 miles from home. Then we will do for the third category 500 and 1000. 0.2 for the students, 0.13 for the parents. So 0.2. 0.2 is right over here. And it is 0.13 for the parents. So it is between 0.1 and 0.3. So this is 0.13. And this is 0.20. So more proportion of students more proportion of students want to stay or go to college which is between 500 and 1000 miles away from the home. It's only in the second category that we see the relative frequencies for both students and parents are about the same, which is between 29 to 31%. Okay. The last category, greater than 1000, for students it is 0.17, which is close to 0.2 or slightly less than. So this is 0.27, sorry, 0.17, close to 0.2 but less than 0.2. And for parents, it's only half of that. So for parents, it's something like this. This is 0.08. Okay. So we compare on the similarities and difference. Similarities in relative frequency. In relative frequencies. In relative frequency. As we discussed, it is in the second category. Between 200 to 500 miles. It is 0.29, and for students, I'll write it with the S, and 0.31 for parents. About the same. Okay. Differences, big difference is big difference in relative frequency is more than 1000 miles. more than 1000 miles. More than 1000 miles, the last category. So, for students, it is 0.17. 17% of the students would like to go to college that is more than 1000 miles away from the home. And for parents, it is only 0.08. Half. Parents are not thrilled at their children going to college which is more than 1000 miles from the home. So similarities in the second category, dissimilarities in the last category. Okay, we are doing a relative frequency comparison. Relative frequency comparison, where relative frequency is on the vertical axis and the categories are on the horizontal axis. Relative frequency on the vertical axis, categories of distances are on the horizontal axis. Okay, relative frequency comparison. We have two bars side by side because we have two types of people, the students and the parents. What is the advantage of this side by side comparison? In a relative frequency chart, you can see the difference in percentages between students and parents. Remember, this relative frequency when multiplied by 100 will be converted to percentages. For example, if you look at the second category here, 29% of the students would like the college between 250 and 500. Here, 31% of the parents would like the college to be located between 250 and 500 miles away from the home. Very similar. Whereas if you go to the last one, more than 1000 miles, 17% of the students would like that. In case of parents, only half, 8%, less than half actually, would like the college to be located more than 1000 miles away from the home. Okay, so let's go to the other side of the board and work on a stem and leaf plot problem. Okay, if you have any question, please do not hesitate to write me a comment. For those of you who don't know me, this is Dr. Nandi. I lecture frequently on statistics. I have also solved lots of problems on statistics, algebra, calculus in my channel. So please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And if you like this video, please give me thumbs up. That really motivates me. Let's go to the other side. So I'll rotate the board. So here is the second problem. The following this we are going to do a stem and leaf plot. The following observations represent the percentages of drivers wearing seat belts in a national study So first we have states with seatbelt law enforcement. And remember, these are percentage numbers. So 95, 88, 74, 97, 85, 91, 93, 88, 87, 93, and 94, and 90. Okay, next row. 92, 85, 86, 84, 85, 92, 93, 94, 78, 87, 92, and a 90. Then 90, 86, 97, 87, 90, 68, 87, 90, 94, 97, and 84. So these are percentages of drivers wearing seat belts in these states. And these are states with seat belt law enforcement. And then states without seat belt law enforcement. Without. Okay. 87, 82, 80, 76, 78, 74, 70, 94, 70, 81, 85, 83, then 68, 83, 84, 84, 77, and 79. Okay. Says A, construct a comparative. Comparative means you're going to compare between states with seatbelt law enforcement and states without seatbelt law. Comparative stem and leaf diagram. Stem and leaf diagram. Okay. Part B, write a few lines on the difference in seatbelt use in the two categories. In the two categories of seatbelt law enforcement. So remember the top one is where they enforce seatbelt law. The bottom set of data is for states without seatbelt. So, what is stem and leaf all about? In these 2-digit numbers, the leaf is the last digit on the right. Okay. For example, here the leaf is 5, here the 8, here is 4, and so forth. And the stem is the number on the left, or the stem is the number on the tens place, 9, 8, 7, 9, etc. And the leaf is the number in the ones place, 5, 8, 4, 7. Okay. So quickly we look and we find in all of this 68 is the lowest here as well as here. Okay. So since we are going to make a comparative stem and leaf plot, we will have the stems in the middle. Again, the stems are the numbers in the tens place. Lowest number is 68 in each. Okay. Now I will do two categories for 6. I will explain to you in a minute what it is. 6 low and then 6 high. Okay. Then the next number I find is 7. Again 7 and low and 7 high. So what is 6L? 6L is 6 low. It is from 60 to 64. And 6H, 6 high. That means stem is still 6, but numbers are from 65 to 69. And same applies to the other numbers in the tens place. 8 low, 8 high, 9 low, and 9 high. Okay. So again, low is from 60 to 64, high is from 65 to 69. The lowest in each category is 68. 68 over here, 68 over here, which is, I will do the lips with a different color. 68 is 6 high, because 6 high is from 66 to 69. I mean 65 rather. This is 55 to 69. So 68 falls. So this side I will do states with law enforcement. The lifts will be for states with law enforcement on the right hand side, and on this side I will do states without WO law enforcement. The stem, so this is the stem. These are the stems, this column. The leaves will be here. So these will be leaves and this will be leaves also. We do not have anything in 6 low. The lowest for each category is 68, which falls in 6 high. So there is a 8 over here as a leaf. 68, number 6 is stem, number in the tens place. Leaf is number in the ones place. 68 for both. Okay. Next, 7 low. Okay, 7 and low. That means from 70 to 74. Okay, from 70 to 74. I look up here. Is there any 70 between 0 and 4? There is a 74 here. No other low 70, so it's a 4 here. How about this one? Okay, this one, let's see, there is a 70, there is another 70, and there is a 74. Remember, low is from 0 to 4. So here are the leaves on states without law enforcement. 70, there are 270, so 2 zeros and 1 4. Whereas for states with seat law enforcement, there is only 174. Next, we go to 7 high. Remember, 7 high is from 75 to 79. 75 to 79. Okay, so I'm first looking at the states with seat belt law between 75 and 79. Let's see if we can find. So there is a 78 here. That's it. Okay, so this is a 78 here. Okay, then let's look at the states without seat belt law. There is a 77, actually there is a 76, 77, 78 and 79. So 76 comes first, okay, then comes 70, sorry, yeah. So 76 comes first, then comes 77, then comes 78, and then comes 79. So there are 4 lives in the 7 high category for states without law enforcement. Okay. Now we are going into 8 lows. Remember, 8 low is from 80 to 84. 80 through 84. Okay. So I'm doing first the state with seatbelt law enforcement. How many 80s through 84? There's one over here. There's one over here. Okay. So there are 2 4s on state with law enforcement. These are the leaves, 284s. Then let's look at the states without seatbelt law enforcement. There's 80 over here, 80 over here, so we put a 0. There's 81 over here, 81, okay. Then there is a 82 over here, 82. Then there's 83 over here, 83 over here, 2 3s. These, remember, these are the leaves, okay. And there's 84 here too. Okay. So 8 low is gone, between 80 and 84. High number of leaves in the states without law enforcement. W/O means without. Okay. Then we are going into 8 highs. Remember, 8 highs start from 85 and goes up to 89. So let's look for 85s first. Here there is 85, so we write a 5 over here. Here there is an 85, there is a 5 over here. Okay. Here there is an 85, so we write another 5. 3 5s mean 3 lives of 5s, or 3 85s. Okay. No more 85. Next number is 86. There is 186 over here. Okay. There is 186 over here. Okay. Then we are looking for 86 is done, then 87. How many 87s are here? Okay, there is 187 over here. So 1 7. Any other 87? No. There is 87 over here. Okay. Then there is 87 over here. Okay. There is 87 over here. Okay. Then we are looking for, all the 87s are gone. Now we are looking for 88. There is one 88 over here. There is one 88 over here. Okay. Second row we are looking. Any 88s? No. Third row I'm looking. Any 88s? Any 88s? No 88. Okay. So 88, and then we are looking for any 89. No 89. Remember 8 high is from 85 through 89. Okay. Then we are looking for 9 low. 9 low. Low is from 0 through 4. Okay, 0 through 4. That means 90, 91, 92, 93 and 94. If we look at the states without seat belts, no, there is only 194 over here. Okay. Oh, I forgot the 8 high. Okay, 8 high. 8 high for states without enforcement. 8 high again is from 85 through 89. Okay, so there is the 87 here. I can see, and there is 85 here. Okay, so there is a 5 and a 7. Okay, then we are going to look for 9 lows. Okay, so let's look for 9 low between 90 and 94 in the top row. There is a 91, there is a 93, there is a 90. Okay, okay, 90, 91, 93. Okay, let's only look for 90s first. 190 over here. Any more 90? There is 190 over here. Then there is 190 over here. So all the zeros means there are 3 90s. And then there is a 490 over here. Okay. Then we will look for 91. Only 191. Okay. Then we will look for 92. There is 192 over here. There is 192 over here. So 2 92s. Any more 92s? Let's see if we missed any more 92s. We got 2. Actually there is 3. 3 92s. That's why 2 appears 3 times in 9 low. 3 92s. After 92 comes 93. How many 93 are there? 1, 2, 2 93s. Is there any more? Yes, there is one more. 3 93s. Next is, how many 94s are there? How many 94? There is 1 over here, 1 over here, 2 over here. So I got 2 94s. Is there one more 94? That is the question. So let's look carefully. 1 over here, 1 over here. Yeah, there is a second row, there is a 94. So 3 94s. Okay. Any more 94s? No. Okay, so let's look on the states without seat belt enforcement. Is there any number in the 90s? Yes, there is a 94. So we entered this 94 over here. Then we are going to look for 9 high. Starts from 95. First 195. Any other 95? No. So 9 high is 95. Then 96. Is there any 96? No. Okay. 95, 96, then we are looking for next number, 97. There is 197 over here, 197 over here. So we have identified two 97s, and there is a third 97 over here. So three 97s. So this is your comparative stem and leaf, okay? The stems are in the middle, 6 lows from 0 to 4, 60 to 64, 6 highs from 65 to 69. In both of these states, the lowest is 68. Hence, a leaf of 8 in both the cases. States without seatbelt law enforcement, with seatbelt law is also 68. Then we go for the 7 lows from 70 to 74. State with seatbelt law enforcement, 74. There are two 70s without and 174 and so forth. But if you compare between states without seatbelt law and with law enforcement, look at the class. 8 low, highest number of leaves, again leaves are numbers in the tens place, is 8 low for states without. This is the class which has the highest number of leaves. Center of the data will be in this. Center of data will fall. Why? Because it has got the maximum number of leaves. Will fall in 8 low. In this side, 8 low. However, if you look at the states with seatbelt law enforcement, you will see maximum number of leaves appear in 9 lows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And 8 high is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is the class. So highest number of leaves, is in the class 9 low. Remember, 9 low means 90 through 94, and here 8 low means 80 through 84. So what is the conclusion? Okay, conclusion is the percentages of people wearing seatbelt is highest in states with seatbelt law enforcement. Okay, and there is a 10 percentage point. 10, as you can see, the highest here is between 80 and 84. The highest here is between 90 and 94. Exactly 10 points. 10 percentage points difference between states with enforcement, and without enforcement. And this is where the center for This 10-point difference is, this difference is shown, this difference is in the location of the center. Remember, the center is the class with the highest number of leaves, is in the location of centers. What is the bottom line? Bottom line is where seatbelt law is enforced, more higher percentage of people are wearing the seat belts. And to be precise, there is a 10 percentage point difference in the centers between the states without law enforcement and with law enforcement. Without law enforcement, it is in 8 laws, between 80 and 84%. With seatbelt law enforcement, it is in 9 laws, this class. Okay, between 90 and 94. Okay. So again, let me repeat what I did. These are the percentages, two numbers, one number in the ones place, one number in the tens place. The number in the ones place are the leaves, the number in the tens place on the left are the stems. Okay, so we have the stems in the center. Why? Because we are going to do side by side comparison. We divide each 10 into 2. For example, 6 low is between 60 and 64. 6 high is between 65 and 69. Similarly, 7 low, 7 high, 8 low, 8 high, 9 low and 9 high. Each of the numbers on the right and on the left are the leaves. So for example, in the 8 low states with seatbelt law enforcement, there are only 284s. That's why 4 appears twice. With the no seatbelt law enforcement in 8 laws, there are so many entries, so many lives in the states without seatbelt law enforcement. It's 80, 81, 82, 83, 83 and 84. This is the class or the stem with the highest number of leaves in the states without enforcement. This is where the center of the data is, between 80 and 84%. On the other hand, states with law enforcement, seatbelt law enforcement, the class with the highest number of leaves in 9 low, between 90 and 94. So there's a distinct difference. This is 80% in the 80 to 84%. This is in the range 90 to 94%. Bottom line, more people are using seat belts when the seat belt law is enforced. Okay, so I will stop here today. This is an example of stem and leaf diagram, and we did a side-by-side comparison of two categories. Okay, so it's sometimes called side-by-side comparison, comparative stem and leaf. Okay, I stop here today. I want to remind you, if you have any question, just shoot me a question in the comment and I will respond to you every time you ask me a question. No question about it. And if you like my presentation, please give me a thumbs up. I really appreciate that. That really motivates me to produce more video. And if you like my video, please share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. At that time, please do not forget to click on the notify bell button. That way you will be notified on your cell phone whenever I'm uploading a new video, which I do quite often. Thank you very much for taking the time to watch my presentation. Thanks a lot. I'll stop here today. I hope you have a great day and I look forward to see you next time. Please do not forget to check me out tomorrow when I'll be doing another presentation. Bye bye. Take care. Have a nice day.